Hello everyone. This presentation is about water cement ratio, the importance of water cement ratio in concrete. Even though it appears to be a simple ratio between cement and water, it plays an important role in determining the strength, durability, workability, and service life of the concrete. Let us understand what the water cement ratio means. Water cement ratio is the ratio of the weight of water to the weight of cement used in a concrete mix. For example, if 180 kilograms of water are mixed with 400 kilograms of cement, the water cement ratio is 0.45. In practice, this ratio usually ranges between 0.35 and 0.65. The importance of this ratio was established by Dr.P.S. Abrams in 1918 through what is known as Abrams' law. According to this principle, for a given set of materials and proper curing conditions, the strength of the concrete depends mainly on the water cement ratio. This concept still forms the basis of modern concrete mix design methods. Let us see how water cement ratio affects compressive strength of the concrete. A lower water cement ratio produces stronger and denser concrete because there is less excess water to leave behind pores after evaporation. On the other hand, higher water cement ratio creates more capillary pores in concrete, making the concrete weaker. In fact, an increase of just 0.05 in the water cement ratio can reduce the compressive strength by 5 to 10%. The next important aspect is durability. High water content increases the porosity of the concrete, allowing water and harmful chemicals to penetrate easily. This leads to several durability problems such as increased permeability, corrosion of reinforcement due to chlorides and carbonation, chemical attack from sulfates and acids, and in cold regions, freeze thaw damage. Therefore, controlling the water cement ratio is essential for ensuring a long service life of concrete structures. There is a trade off. A lower water cement ratio gives higher strength and durability, but it also makes the concrete difficult to place and compact. A high water cement ratio improves workability and makes placement easier, but reduces the strength and durability of the concrete. Instead of adding extra water to improve the workability, we can use superplasticizers or water reducing admixtures which maintain workability without increasing the water cement ratio. Another important effect is on shrinkage and cracking. Excess water causes more bleeding and evaporation, resulting in plastic shrinkage cracks. As the concrete hardens, additional water loss leads to drying shrinkage, increasing the chances of long term cracking. To ensure durability, building codes recommend maximum water cement ratios based on exposure conditions. For example, 0.55 is generally acceptable for mild exposure, 0.50 for moderate exposure, 0.45 for severe exposure, and 0.40 for extreme environmental conditions. Let us summarize the consequences of using an incorrect water cement ratio. If the ratio is too high, concrete becomes weaker, more permeable, and more susceptible to bleeding, segregation, shrinkage, and cracking. If the ratio is too low, concrete becomes difficult to place and compact, leading to air voids and honeycombing unless suitable admixtures are used. To conclude, water cement ratio is the single most important factor controlling the quality of concrete. Maintaining the correct ratio ensures optimum strength, durability, and performance. So, we should remember this simple principle: never add extra water to solve a workability problem. Instead, we can use appropriate admixtures, control the water, we can control the concrete. Thank you.